A very good morning, my dear students. Today we will solve a third method problem in module 2. Okay, that is the unbounded simplex method problem. Okay, so far we studied about the two different types of problem, that is simplex method and the big M method. Okay, so this problem is also very important for the point of examination. So the unbounded means here we not get any entry variable. Okay, so only living variable we will get, but entry variable not get. Such problems are called as unbounded simplex method problems. Okay, so question is given like this. Solve the following LPP using simplex method. Okay, so same procedure is a simplex method. At the end moment, you will not get the entry variable. So that is the only difference. Okay, so such problems are called unbounded problems in simplex method. Okay, so the question is given: solve the following LPP using simplex method. Okay, maximization is equal to 3x1 plus 4x2 is equal to z, and subject to a constant of x1 minus x2 is less than equal to 1, and minus x1 plus x2 is less than equal to 2, x1 comma x2 is greater than equal to 0. So same procedure what we are going to solving in simplex method, that only method we are going to follow here also. So okay, so here they given less than equal to means you add a slack variable. Okay, same that I will first step is to convert all the equation into equal one. Okay, yeah, so first equation is x1 minus x2 plus s1 is equal to 1. Why we are adding here s1 plus s1? Because in the given question they are given in the less than equal to 1. So for less than equal to 1 we are adding a plus s1, greater than s equal to is means you are subtracting. Okay, so s1 is called as a slack variable. So similarly second equation is minus x1 plus x2 plus s2 is equal to 0. So the modified equation, that maximization equation, is equal to just these two slack variable you add into and consider their quotient is 0. So the modified equation is equal to maximization z of is equal to 3x1 plus 4x2 plus 0s1 plus 0s2. Okay, so first this is about the first step. Second step is by using this you construct one simplex table. So here this table is called as simplex table 1. So for simplex table is common for all the type of problem. Okay, so in first column they given cbj means basic variable coefficient. Okay, now in this side basic variable, and top cj means coefficient of objective. Okay, and this side is the right hand side is solution and ratio. Okay, so first we have to fill the basic variable row. Okay, basic variables are these: x1 x2 s1 s2. Okay, right here x1 x2 s1 s2. Okay, next second equation in the top cj means coefficient of basic variable. For the x1 coefficient is 3 is there, x2 coefficient is 4 0 0. In top you write. Okay, so here I shown 3 4 0 0. Okay, so that is the coefficient of basic variable, and this side is slack variable. How many slack variable are added here? s1 and s2. Right here s1 and s2, and their coefficient is 0 comma 0 in the cbj column that you have to write. So once you fill all the details in the given simplex table, then go for calculating the z value. So how to calculate the here zj value? So 0 into 1, 0 into this 1, this x1 row 1, 0 into 1 plus 0 into minus 1, you will get 0. Okay, so similarly find the second column row. 0 into minus 1 plus 0 into 1, you will get a 0. So like that go on, solve all the respective row, you will get. So here zeros are there, so anyway if you want to multiply 0 with any number you will get 0 0 0 only. So zj values for the all the values is 0 0 0 0. Okay, so now calculate the cj minus zj values. So stop at the top, cj is there, zj already calculated, so subtracting from cj minus zj value you will get this. Okay, here 3 minus z is equal to 0, 4 minus 0 is equal to 4, so 0 minus 0 is equal to 0, 0 minus 0 is equal to 0. So we get 3 4 0 0 is are the cj minus z value. So for this the given question is maximization. So all cj and zj value should be negative and 0, so then only the solution is optimal. But here 2 are positive and 2 are we got 0 0. So for that, for calculate for the maximization from the cj and zj value, observe the highest positive value. So here highest positive value is here 4 is there, so you dark the circle 4 or you highlighted 4. Respective column you select that, you make it as rectangular blocks. Okay, where the highest point, highest value digit will be there, respective column you have to digit. Okay, next once you selected that x2 row, come for the solution. Here in the solution again we have to calculate the ratio. How to calculate ratio? Here the solution divided by the selected column. So 1 divided by so here is there minus solution 1 divided by minus 1 is you will get minus 1. Okay, and this 2 divided by 1 is equal to you will get a 2. Okay, Once you calculate the ratio here, and in this side you calculate the highest value here also. Okay, highest value in this is 2 is there, so you select the 2. In the right hand side I select the respect to whole column, okay, whole row. I put it here in the selected box. Okay, so once you selected, so this selected column is called as a key element column, and selected row is called as a key element row, and one digit will be intersection point, so here intersection point is called as a key element. Okay, so here x2 is for the next table, x2 is entry, and s1 is leaving. So yes, so here is selected this column, so x2 is entry and s2 is eliminated, so you delete s2. Okay, in this column. Okay, so if you want to check the optimal solution is all cj and zj values are either negative or 0, but here not there, so again go for the second table. Second, you have to construct the second table. Okay, so in second table, so x2 is entry and s2 is leaving, so second table should be s1 and x2. Okay, now x2 is leaving, so you cut it or draw a deleted line. This is because this is leaving variable, so for that second table is like this. Okay, we consider second table. So basic variable, both the two column values are same, and this one s1 and x2. Here I wrote x2 because x2 is entry, and s2 is leaving because intersection digit key element is belongs to x2. Okay, and next, how to enter these s2 values in the second column means here the key element is 1, so divide key element with the all respective values. So minus 1 divided by minus 1 divided by minus 1, so 1 by 1 is equal to 1, and 0 by 1 is equal to, will get a 0. Okay, so like that you have to write it, and s2 you are not writing because it is eliminated row. Okay, now s1 top value is how to write. This is formula is there. That is old value minus new value into key column value. Okay, now so old value is 1 and minus new value is here. How much? What is the new value? Minus 1 is there here. So new value minus 1, and key column respective column is also minus 1 is there. You will get 0 like that, 0, and calculate similar way in the other two x2 and s1 values. Okay, once you calculated, you now you calculate the zj value. Again same zj value, same procedure is there. 0 into 0 plus 4 into minus 1, you will get minus 4. Again 0 into 0 plus 4 into 1, 4, and 0 into 1 plus 4 into 0, you will get 0. Okay, so once you calculate the zj values, that is minus 4 4 0, so you calculate the cj minus za. So top is cj is there, zj is there, so 3 minus minus 4 is equal to minus 7, and 4 minus 4 is equal to 0, 0 minus 0 is equal to 0. So here, so highest negative value is again here select that respective column. Okay, but whereas in this case, this right hand side, you calculate the solution. So solution is 0 3 by 0 by 3 is equal to infinity, minus 1 by here 2 by minus 1 is equal to, this is, you will get a minus. So minus sign, you ignore that signature, that sign symbol, so no need to write. So here x1 only the x1 is there, but leaving variable are not there. Entry is there for here selected row ratio is not, we are not going to selecting anything. So for that purpose, so this problem is unbounded. If it is happen a such type of problem, so it come like this, infinity or not selecting any leaving variable, so such problems are called as unbounded problem. Okay, so here right here the highest negative value is minus 4 0 0, therefore the solution is unbounded because here no leaving variables are there here. Okay, now here there is no leaving variable, hence the problem is unbounded. Why it is called unbounded? So in previous problem, so far we studied here entrant variable, so you are selected a key element and key row and key column also, but here we selected only the key column, but whereas no key row element is there, so infinity is there. So infinity means nothing, we are cannot select anything. Okay, so such problem is called as a unbounded problem. Okay, so I think you understand this problem, unbounded problem, how to solve. Procedure is same, at the end moments you will not get a living variable, so such problems are called unbounded problem. Okay, remember this. Okay, I hope you understand this unbounded problem. Thank you.